and I try to work a couple of more of these biomolecules. Correction in my previous recordings, this particular molecule is 2AIZ, not 2A1Z. Thank you, Dr. Jaya, for reminding me. I have a little bit of a cough, sorry. At any rate, so the colorations are all working. We can change all the colorations down to the atoms, bonds. We can change what we're gonna show. Do we want to show just the chains, the ribbons, whatnot? The coloration in this particular case is a bit modified by me to some discrepancy with what is available from databases. I do not know what's causing it. There's a bug at their end. But I mean, if you wanted to find something beautiful in the nature, I mean, you're looking at it. I mean, what can I say? I mean, there are trillions and trillions of this in your body. And if they get destroyed, they will be replaced in the plants and animals. Many such proteins, large ensemble of proteins. And as you can see, this is not a trivial structure. It's not something that we can study with regular physics and mathematics. We understand what we study, the equations that they teach in the graduate schools and solutions and all that. They're approximations. They are not perfect. Majority of the times, they just get guessworks at best. Personally, I have programmed those, and I've spoken to people who know this very well. A lot of arbitrary assumptions and numbers and things and equations have been entered to go forward and see what works. Basically, there are some fundamental mathematics, geometry, and physics that apply to this. The rest of it is sort of winging it. And from molecular software analysis to the other, the results come out very different. My apologies for my throat. Let me drink something here. Okay. What impresses me about this particular molecule is these directed ribbons. I assume that's what they're called. And God, they're beautiful. Look at that. This molecule is dense and complicated. This is something like, something very serious going on here. This is nothing like you see in average if you look at some videos on different places, or kind of chemistry, biochemistry books and stuff. This is wow. At any rate, just wanted Dr. Jaya and Tahar to know that the colorizations are working. And you can zoom in and out. There, to my unfortunate unhappiness, these processes to acquire these molecules are about 90% automated. There's a 10% labor involved, which I would jot down in details. Over the next 1 year, we need to automate the process. But that 90-something% of the task is there. I didn't have it before. Most people didn't have it before. Thanks to all the nationally funded, publicly funded money by the taxpayers of different countries. Huge numbers of international lab workers, scientists, biochemists, and whatnot. Computer scientists and very dedicated folks have worked on these structures to make them available for us for free. I'm thankful and very grateful to all of them without exception. Now comes for us to contribute by bringing these into a new way of teaching, and I hope Dr. Jaya is the right person to take that over and use his brilliant mind to contribute to how to present these things. I mean, we can give him all the computing he ever can imagine, as good as any other lab, any other university, United States or Europe. I don't think there is anybody there can compete with us on that end. And I'm being cocky, and correctly I am so, justifiably so. At this point in time, we will provide fairly large cloud computing models of these sorts of molecules, say several hundreds of these that will be of his interest. They will be accessible to multiple programming languages. And he will be able to program these and turn them into interactive 3D educational content for anybody on the planet to access, hopefully on mobile phones. We may not be able to always provide on all the mobile phones, but pretty much we should be able to do most of the times. At any rate, thank you for your attention, and we'll chat with you very soon.